In the previous video, we got comfortable with our multi-label classification dataset. We visualized the images and looked into the distribution of the class labels. In this video, we will create a customized Pytorch Dataset class in order to load and pre-process our data. Let's get started. Hello everyone and welcome to ML Done. If you're here, it means that you have also struggled with something that most people who start with PyTorch, who get started with PyTorch, struggle with, and it is where you want to actually create a customized PyTorch dataset class. Now today we want to address this problem, but at the same time create a customized dataset class that would encapsulate our multi-label classification dataset. So let's just get started. We need to import the built-in abstract dataset class in PyTorch. So we're going to be importing it from torch.utils.data, right? But I don't want to just, import this and not show you what's inside of it, right? So I have actually found the source code for the actual dataset abstract dataset class. So I just want to show you what's going on inside. Now, first things first, we have 3 dunder functions. Now, if you don't know what a dunder function is, don't worry. So this is basically all the functions that start with 2 underscores in the beginning and 2 underscores at the very end. And these functions can be actually defined to facilitate certain, let's say, arithmetic operations that might otherwise make no sense. I'll tell you in a minute what it means, but you've seen a dunder function very, very frequently, I'm sure, in the past, and it is the constructor of a dataset class, basically, where we have underscore underscore init underscore underscore. So you have this constructor dunder function, basically all definitions of Python classes that you might have worked with so far. So if you notice, you never have to actually call out the init function explicitly. When you create an object of a class, the init function gets called automatically, or one might say automagically, right? So this is the same idea behind these dunder functions as you see here, get, item, len, and add. You don't need to actually explicitly call them. They will be called automatically, but in different ways. And I'll tell you exactly what I mean. For example, you have this let's say len dunder function. And you notice that in the abstract dataset class, we have this sort of line that says raise not implemented error. So this basically means that when we create our customized object or customized dataset class, we need to override the len dunder function as well as override the get item dunder function. This is exactly what you see here, that all other dataset classes should subclass this, and we have to overwrite these functionalities. What does it mean to say the length of a class? So this is exactly what I said in the beginning. It doesn't make sense to say that the length of my dataset class or the object of this dataset class is 5, 10, 20, whatever. It doesn't make any sense. We can actually define what the length of a dataset object means in our code. You see what I mean exactly, so don't worry if you don't get it. But just to give you a very small example, for example, let's say you have 2 strings, right? So one string is John and the other string is, let's say, Marie. So you notice that you can actually say A plus B, like C equals A plus B, and then if you actually look at what C looks like, it's actually the concatenation of the 2 strings. But you and I both know that summation makes no sense when it comes to adding 2 strings together, right? So there is a dunder function underneath in the abstract string class in Python that says that the arithmetic operation plus, whenever that is called, just concatenate these 2 strings together. So it just got called automatically. That's the magic behind dunder functions. That's actually why sometimes they call it magic functions, actually. And I'm not kidding. That's actually sometimes what people call these functions. But I digress. Let's create our multi-label dataset, right? So it is a class like any other class. I'm just going to be calling it multi-label dataset, and it has to inherit from this abstract dataset class, right? So I'm going to say dataset. That's how we inherit. Now, like any other class, we're going to be creating a constructor, right? And again, as I said, constructor is a kind of dunder function, right? So here, as always, we start with the keyword self, and this is where we can actually pass arguments to the init dunder function. Now remember, the dunder function init is called whenever you create an object of a class, right? So it purely depends on you. What would you like to happen when you create an object of this dataset class? What I would like to happen is that I would like my images and my class labels to be loaded. I would like my images to be reshaped or resized if I have to. So for example, if each image has its own dimensionality, one is 32 by 32, one is 64 by 64, I want to make all of them the same size. I would also like to maybe actually normalize my images in the range between 0 and 1. So my data set actually, all of the images, basically the pixel values range from 0 to 255. So if I just divide everything by 255, everything will be normalized nicely between 0 and 1. So I want all of these things to happen the second I create an object of this class. So it means that I have to put all of these steps inside the constructor, right? So this is basically everything that I'm going to do here. 99% you've already seen, right? Almost everything. There's only one little trick that I'm going to play here that might be new to you, but other than that, everything is exactly like what you've seen. Now, I can pass my arguments. I can even have it here. Let me put it this way. So let's say I have my labels path and images path, right? This is exactly like what we've done before. Now, I'm going to basically copy and paste everything that you've seen before, like the way I read the labels, the way I changed the column names, I turned the labels into a one-hot encoding or multi-hot encoding in multi-label classification's case, the way I loaded my images, basically everything copy-paste, except when I'm going to be reading the images, I'm also going to resize each image to make sure that all of the images have the same size. As you see here, the images are of different sizes, and this is not what you'd like to happen, especially when you want to use a neural network to create a classifier, for example. You want all the data to be of the same dimensionality. So over here, I'm going to be doing some resizing, and there's also one other thing that I need to do. Some of the images in this data set, I actually discovered this recently. Some of them don't have 3 channels of red, green, and blue, right? Some of them are uni-channel, they just grayscale. So in other words, I need to actually copy them 3 times to sort of simulate an image having to an image that has 3 channels. So basically stack them on top of each other 3 times to create a 3-dimensional, let's say to create an image that has 3 channels, right? Basically stack them on top of each other. So these are the little things that I'm going to be doing here, right? Other than that, everything is literally copy and paste. So because of that, I don't want to spend too much time explaining each one of the steps. You will have already seen everything that I'm going to be doing. So first foremost, as you've seen before, I would like to read the labels from labels path, right? This is where you've already seen this. This is the first thing that we did in the first video of this series of coding a multi label classifier. And then I would like to, maybe I should just copy this altogether. Just grab the column names of my data frame and then basically rename the big name of one of the columns into just a simple word classes. Remember, this is exactly what we did here. Remember, so this is where after we read the class, after we read the CSV file, this column name was so ugly, so we basically did a renaming thing, right? and then we just turned it into the word classes, right? So nothing is new. 99% is really not new. And then we go over the labels, and let me copy this here. We go over each one of the rows and just grab the chunk that relates to the zeros and ones and for the class labels. And then we just turn that into a NumPy array. Again, something that we've seen before. We grab the image names, right? And then we use these names to actually go through each image name and then grab the images and load them and store them, basically, right? So you notice that here I have self.label. So this basically means that this is going to be an instance variable, right? Like this is just object-oriented programming thing. This means that later on, after I created an object of this class, I can literally say object.labels, and I will immediately have access to this variable, right? So this means that any instance of this class will give me a doorway to have access to these instance variables, right? So let me iterate through the image names, right? I just put a TQDem here for the progress bar. You've already seen this. So get the image path, like images path that we have here, right? Concatenate it with the image name, open it with the image package, and then turn it into a NumPy array. Now this is where I play a little bit of trick, the trick that I told you. Some of these images, as I said, they don't have 3 dimensions, right? They're like maybe 32 by 54, 63 by 64, 512 by 512. So they don't have that 3rd dimension that should have actually 3 channels, right? One for red, one for green, one for blue. In those cases, I'm going to be stacking these images up on top of each other. The whole goal is to make a homogeneous data set. Now, this is where you can actually say that if you grab the shape of this image, of this NumPy array, right, and take a length of it, if it is equal to 2, it means that it doesn't have the channel dimension. So this is where you're gonna be copying this 3 times on top of each other, on top of itself, and then stack them together, but across the last dimension, right? First is height, the second is width of the image, the last one is supposed to be the channel, right? So when you stack them together, you have to tell NumPy, I want this stacking thing to happen along the final dimension, that is the 3rd dimension. So again, here, this is some interesting coding, one might say a little advanced coding. This is where you can create a list, right? This is basically a list. And for underscore, this means that I don't care what this variable is. You can put I, J, whatever you want, doesn't really matter. In range 3. So this means that this thing, like image.copy, will happen 3 times. This is what all this means. And each time it will be appended to this empty list, right? So by the time this line is executed, it means image, which is a NumPy array, has been copied 3 times and put in 3 different places, or 3 consecutive places in an empty list, that by the end of which it will have 3 elements, 3 identical elements actually. And this is basically what you call list comprehension. So instead of creating a for loop like explicitly, and inside that for loop actually stacking images on top of each other and appending them in an empty list, you can actually do all of that in one line, and that is exciting. That's almost advanced coding. Now you need to ask NumPy to concatenate the elements of this list into concatenate them into one NumPy array, but concatenate them along the final dimension. And by concatenation, you can actually do that by the command numpy.stack. So basically, you're literally stacking the elements of this list together across the final dimension, right? So axis is -1. -1 means the last dimension, right? So So if image has the shape 32 by 32, by the end of this line, after this line is executed, this image, the image will have the dimension 32 by 32 by 3. And if you look at each one of the channels, this is the exact same image with the exact pixel values, only copied 3 times, right? This is just simulating an RGB image from an otherwise grayscale, like a grayscale boring image, let's say. So I just put this guy here to make sure that anything that passes to this part of my code will already have 3 channels. So everything is consistent right now. Now, this is where I'm also going to resize my images, just to make sure that all of my operations will go more sort of faster, just to avoid wasting time, because right now, creating the best multi-label classifier is not my objective. This is just to show you how to deal with, how to create custom dataset classes and how to create, multi-label classifiers. So I'm going to be using CV2. I've already imported this. I think I have. If I haven't, let me just import CV2. So this is the package that you can use you can do many things with CV2. One of the things that you can do is to actually resize images. So you say cv2.resize, you pass your 3-dimensional NumPy array to it. It assumes that the final dimension is channels. So if your image is not, you have to reshape it such that the final dimension is going to be number of channels. First and second dimensions are going to be height and width, right? So after this line, the image, if it has dimensionality of, let's say, 64 by 64 by 3, after this line, it will become 32 by 32 by 3. So anything that passes this chunk of the code will definitely have the dimensionality of 32 by 32 by 3, right? So everything is absolutely consistent. After this, we can just append this image, because it has passed all the quality tests. We can just append it to our instance variable, self.images. Remember that self.images, I think we have not defined this here. I also actually never defined self.labels. Sorry for that. I would have run into an error anyways, but so let me just put images here. So I'm going to be defining both of them as 2 empty lists, basically. So that's how I can actually append to it here. By the same logic, I'm going to be appending these images to my instance variable self.images. So this loop, by the time this loop ends, I will have all of my images stored in self.images list. And finally, you need to turn it into a NumPy array. I mean, you don't need to, but this is just my habit. I always like working with NumPy array. So it's like simply self.images equals NumPy array self.images. And what else? Yeah. I'm gonna create a function called normalize inside my class, and this will basically just do the job of dividing all of my images inside self.images by 255, just to normalize the pixel values of everything between 0 and 1. End of story. So it will return, or maybe it doesn't even need to actually return, really, to be honest with you. I can just do self.images equals self.images divided by 255. I mean, that's it. You don't even really need to return it. Great. So all of this is pretty familiar, right? Now, the big thing that I told you about is overriding these 2 functions. Now, what does the length of my object mean? So def dunder len, right? What does it mean if I want to see the length of my object? Right, that's a legitimate question, isn't it? So I can just say, well, this class or the object of this class is going to be holding a bunch of images. So how about the length of this class or the object? How about the length? We can make the length mean actually the number of images inside, right? So I could just say this is basically return self.images.shape 0. Right? Also, what about get item? What is this? What will this return? So you can actually pass an index to this. You'll see how we can actually use this in the future. But you can actually pass an index to this and basically iterate over the elements or retrieve elements from this data set, or like retrieve images and their corresponding labels. So that's the whole point. Here you want to, given an index of an instance, you would like this get item to be called automatically, and you would like it to return an image and its corresponding label, like 001100, right? So in order to do that, I'm just going to create a variable, and I'm going to create, define sample as a dictionary, right? And just to save time, I'm going to be copying this here. So it has two keys, images and labels. Now, this will return the image living at index IDX in my self.images, and also this will return the label vector that lives in the index IDX in self.labels. Right? So this is going to return this dictionary. Okay, it seems that everything is okay now. I just had to change the directory here. It was wrong. Also, I had to call my normalize function. I forgot to call them, and also had to unindent these three functions. They were actually one level in too much. They were inside my constructor. Obviously, you shouldn't do that. So I just had to de-indent them one level. So everything seems okay. So let me see if I can actually create. First, run this, and then let me see if I can create an object of this class. So when you do that, what's happening is the constructor and the class will get called automatically. And you notice that I didn't have to call the constructor explicitly because it's a dunder function, and it just gets called automatically the second you create an object of this class. And what's happening now is everything inside this dunder function is being executed automatically. So the class labels are loaded, the images are loaded, the images that have only 2 dimensions, they've been stacked up and created and turned into a 3-dimensional NumPy array. They've been resized to only 32 by 32 pixels, turned into a NumPy array, and that's it. And then also normalized, right? And that's it. So, okay, everything ran successfully. That's great. Now I want you to get a little bit comfortable about the functionalities of these two, especially these two functions, right? Now, what does it mean that they will get called automatically? It means that if I say what's the length of my object, this should return what? This should, first of all, call this dunder function automatically, and it should return the first dimension of my self.images NumPy array, right? Remember, it's a 3-dimensional. Actually, let me show you what it looks like. If I go inside my object, go self.images.shape, you see it's a 4-dimensional array. So if I say what is the length of my object, this will return the first element in my shape. So this should return the first element in this shape, right? So if I just do that, exactly the same value, right? One other thing, I said that this dunder function is going to help us retrieve items from the dataset object, right? So this will give us the ability to do simply this. Give me the data, the image and the corresponding label to that image that lives in index 12, right? When you do that, it returns a dictionary, exactly how it's supposed to do, right? This is a dictionary. The key is images, as we have defined here. The other key is labels, as we've defined here. Inside labels, there's a numpy array of the multi-hot encoding vector, and inside images, the value corresponding to this key in the dictionary is the actual numpy array. And you notice that we see a lot of ones and some values other than 1, because this is because we have already normalized this data between 0 and 1. So no value would, exceed 1 and go below 0, obviously. So this is the advantage of having these dunder functions. They just get called automatically very, very nicely, right? One more thing I want to show you before I wrap this up is something that people usually don't talk about much. And it's that inside this dataset class, we have this functionality called add, right? And you might wonder what the heck this is. When would you call add functionality, right? I'm going to show you exactly what it means. Let me maybe erase this. I'm going to create another object of my dataset class. I think the second I said I'm going to create another object, you might have guessed where I'm going with this. While this is being created, I want to explain what's going to happen. If I have two objects of the same class, you might want to concatenate objects together somehow, right? Objects of the same class. So this is where, if you actually literally add them up, this is where this dunder function is called automatically, like the same way that you would add two strings together and it concatenates them together. If you add two objects together, this dunder function will get executed, and inside the source code there is also a functionality called concat dataset that I haven't pasted here, but it is there. That is why I imported the dataset class directly from torch.utils.data, because it has all the sub packages that this abstract dataset would need, which is in this case concat dataset. That is why I'm not running this cell, I'm running this cell to make sure that everything inside, everything that the dataset class needs is inside of it, right? So great. Now let's say that I want to add the two objects together. Boom! When that happens, you actually have used this dunder function, right? Remember that you didn't have to overwrite this conversely to these two, right? It's already been implemented for you, right? That's why you usually in tutorials you don't see people, overriding and writing, overriding the add functionality and writing def __ add __ because it's already there. You can use it. Now, can you guess? If I say what's the len of D, I get this value. If I say what's the len of D1, I get again the same value, right? These are copies of the same class. But if I say what's the length of D3, do you know what will happen? It's actually twice this value, like this value plus this value, because it's now two objects concatenated together. Right? By the same logic, you can use getItem dunder function to retrieve all the images inside, like combined between the two dataset objects. Okay, great. You've done great. Well done. I know this was heavy, but this was critical for you to understand and get comfortable with. Okay? So from now on, anytime you want to create your own project, Pytorch project, you can easily create your own custom dataset class, no problem at all. In the next video, we're going to be going over the concept of data loader, and I'll show you how you can use a data loader to actually iterate over your dataset class object and also retrieve data samples, because you will be needing data loaders to actually iterate over datasets and actually input the retrieved data samples to your multi-label classifier, for example, a neural network. I see you in the next one.